Okay, this robot problem tickled my brain a little bit, but after seeing this example, I realized that I'm working with a not a permutation but a combination. So I know the robot can only take a set number of steps, and there's only so few combinations it can take between all the downs and rights. So there can only be limited number of rights it could take to get to the finish line. So after I thought about it for a while, it turns out to be just a combination. So see, I understand that the input is two numbers, two integers. Output is a combination. So, but not exactly a combination of those exact two integers. I have to, since the robot already takes up the first square, it's -1 for each of the squares. So the input would be, let's say, example. Input is 4 and 6. I'm not working with 4 and 6 since the robot takes up one square. I'm working with 3 and 5. And with 3 and 5, the robot needs to take 8 steps. So it's robot takes 8 steps because of 5 and 3. So yeah, 3 plus 5. From the 3 plus 5, it needs to take that many steps to get to its goal, no matter what. Always takes 8 steps. And between the 8 steps, there are only two combinations, right and down. And depending on how many rights it can, there's only a limited amount of rights it can take, and limited number of downs it can take. And it's actually, it wasn't that hard to think of the solution once I saw that it's just a combination problem. So it's actually just, so if it's 3 and 5, it's the answer should be only 8 combination 3. The is always 8 combination and the smaller number 3. Actually, I think it's the same answer if it's 8 combination 5, because 8 minus 5 is 3. I think I'll come up with the same conclusion. But for anyhow, this answer works. 8 combination 3. So the answer is just that. Matching, well, any other factorial problems, any of the calculating, like finding the first digit, and I guess counting the zeros, you'll need to find a factorial for that. Finding the first non-zero last digit, that also finding the first or the last non-zero digit, that also requires calculating the actual factorial. So these are what I'm going to match with. I'll know I need 2 loops for this problem. One to find the combination numerator and the denominator. and some if conditions to find a bigger or smaller number. Yeah, that's it. If conditions to find smaller, bigger number between the two. So plan is just to take user inputs, subtract by 1 with each number given. Get the sum of those two numbers, and then find a combination. Well, use the two for loops to find a combination. So it'll be for loop. It's not exactly. I'm not exactly finding a numerator, but the like if it's 8c3, I'm immediately finding 8 factorial divided by 3 factorial in this single for loop. So this for loop from the range of 8 to 3 and multiplying the i's. So it's just numerator is equal to plus equal all the i's from 8 to 3. Did a second for loop to find the factorial of 8, not 8, but the bigger number, which is 5. Technically the numerator should be just 8 minus 3. So I'll just say that 8 minus 3 instead of skipping step. So for loop of 8 factory 8 minus 3, and I'm actually looking for the factorial, so the range is from literally 5 to 0. Range 5 to 0. And so that means denominator is equal to, let's call it J. I'll put this in the next line. And then my answer should be is just numerator divided by denominator. And that's what I just need to return at the end. And I know they're always integers, and since I'm working with combinations, I'm never going to get a decimal. So at least I think I won't get a decimal. So floor division, numerator divided by denominator, and that gives me the answer for the how many unique paths it can take.